Okay, thank you, well done, for inviting me here for today in order to proceed with our lesson, particularly in the lesson of chemistry, in which our objective for today we are much concentrated on Zeroth law of chemical thermodynamics. But our subject today is chemical thermodynamics. Before proceeding, we are supposed to trace, when we talk about the Zeroth law of chemical thermodynamics, or when we talk about chemical thermodynamics, we are supposed to reveal or to trace back and to remember about the quantum mechanics, not only but also statistical mechanics. Because here we are just dealing with the energy, which we are dealing about the energy which is possessed by the system of chemical. When we are talking about the chemical thermodynamics, we are talking about the changing in the system of the chemicals. So here we so when we talk about the chemicals, the concept of the changing the chemical system means that the data in which we can obtain after calculating, that data we are going to insert in terms of the quantum mechanics or statistical mechanics. So whatever we do, but at the end of the data which you can obtain from the system, you are going to apply that data, or you're going to use that data in terms of the statistical mechanics, particularly in the quantum mechanics. But before proceeding, this is statistical mechanics introduced after the invention of statistical mechanics, and quantum mechanics introduced after the Newtonian mechanics, or so this introduced so the issue of statistical mechanics and quantum mechanics introduced after the failure of the classical mechanics. So the failure of the classical mechanics led to the development or invention of the quantum mechanics. So there is a relationship between quantum mechanics as well as chemical thermodynamics. So today we are much concentrated on the chemical thermodynamics and the classical mechanics introduced by the Newtons, or call it Newtonian mechanics. But for today, we are much concentrated on the chemical thermodynamics, particularly in the Zeroth law of chemical thermodynamics. When we are talking about the Zeroth law of chemical thermodynamics, here we are talking about the chemical system. We have the chemical system. So you need the chemical system. We are evaluating its dynamics or its changes. So here the law of chemical thermodynamics says that if system A is the thermal equilibrium with the system B, and the system B is thermal equilibrium with the system C, also system C is thermal equilibrium with the system A. That is the very simple on how to explain about the Zeroth law of chemical thermodynamics. As this has been said there, is that the law of chemical thermodynamics said that if system A is the thermal equilibrium with the system B, and the system B is thermal equilibrium with the system C, also system C is thermal equilibrium with the system A. Let me show how it can be explained in very simple. Can have system A here, can have system B here, then you can have system C here. What we're talking here is that if system A is thermal equilibrium with the system B, is thermal equilibrium with the system B, and the system B is thermal equilibrium with the system C, means that the system C also is thermal equilibrium with the system A, means that system C also is the thermal equilibrium with the system with the system A. So here when talking about this one, we are talking about here that if system A is thermally equilibrium with the system B, and the system B is the thermally equilibrium with the system C, also system C is thermal equilibrium with the system A. So that is how temperature changes. Here we are talking about the temperature. So if system the Zeroth law of chemical thermodynamics says that if system A is thermal equilibrium with the system B, and the system B is thermal equilibrium with the system C, also system C is the thermal equilibrium with the system A. That is very simple on how to state about the zeroth law of chemical thermodynamics. So up to here, let me say thank you my learners from Uganda, thank you my learners from Tanzania, as well as thank you my learners from Kenya, but also thank you my learners who follow that my lessons around the world, but also thank my learners who participate in this lesson in terms of face-to-face lessons. So up to here, let me say bye bye, enjoy chemistry, enjoy chemical thermodynamics.